Right, so there's apparently several billion gallons of oil and gasoline that is trapped in the bottom of the ocean in different shipwrecks. And so the question is whether or not to just let billions of gallons pollute the ocean, or how to respond. And as we move into artificial technology and robotics, one of the possible funds that can be created as costs lower is a nonprofit specifically designed to be self-sustaining by harvesting and safekeeping that oil. So water's up here, and here's one of the approaches that can occur either with a single or a couple of people or completely unmanned. So first we have the boat, a GPS-controlled robotic boat with several self-launching submarines that, through the best technology available, drones, sonar, metal detection, I'm not that up on that, drop down and scan for wrecks. Now, once a wreck is found, it should be relatively easy to launch enough probes to determine if and where how much oil or gasoline is on board. And there's a couple of different technologies that can be used, and it will vary over time which one is most effective. But once these small electric-powered submarines, so a couple of distinctions, the main ship can run on the gas and diesel and oil generated from the wrecks, but the little subs, etc., can be electric. And the process would be send down a sub and then find whether it's going inside of the different rooms of the ship. The micro sub, it needs propulsion, of course, but it also needs boring capacity. It needs a surface driller, basically, with diamond bits that's slightly bigger than the tube, in order to facilitate drilling through various shipping containers. And it needs a drill that's in front that's very small as kind of a gauge, because you don't want to drill through and open up an oil area and start a leak before you've developed the ability to exploit and pull the oil up. But once you have a tube with propulsion in the back with slight steering ability, and you have a front face that is slightly bigger than the tube and can drill, now you've got momentum of the drill, angle of drill, and the ability to drill right through and then continue navigating through a boat, meaning you could angle up to the side, start drilling, and then go through the vessel as part of the hunting for oil. The next thing I think that's important is a locking ability. And if we have a plate of metal and we start with our drill right here. And I think this would be a hollow, a core drill. Then you have the small drill bit at the front of a core drill. You have the core drill itself, and then the core drill needs to attach at several points. However, there is a clamping mechanism where once the core hole is open and tapped through, the very process of pulling a clamp out like this pushes the circular hole off of the core front bit, and simultaneously goes into the plate and attaches the device to the plate. You now have the propulsion motor, which becomes a pump to extract material in the hull that has just been penetrated. This now provides the opportunity for a second submarine device to be launched down with an expanding or retract, with a hose. Could be 2-inch, could be 4-inch, could be 6-inch, with a hose that comes down and then attaches to the back part of this sub here. Now you've got a hose going up to the hull of the boat. You've got this clamped on, and with this hose that comes down from the boat, you have electric power that clamps onto the first area, or the first bot that has made the hull penetration. So now you've got continuous electric power. You've got new fuel coming up to the boat, and there'd probably have to be a micro refinery so that in no event would you run out of fuel. And certainly parts of the boat can be solar powered, because this entire, you probably have a deck just so that people could operate on it. You can have a solar roof over the entire boat, and you can now have modules of these boats, each with their own engine, that add additional tanks, so that you have a core tanker and explorer, and then you have self-propelled additional tankers that are modular, that don't have all the same equipment, just a shell motor, with an electric battery and solar panel that would navigate then towards any tanker that has discovered more oil than they can fill a single tanker with. Once an area, or once a tanker is filled up with waste oil, then the entire thing can navigate to shore, where the oil can be sold on the open market to fund the non-profit goal of extracting all oil from any ship beds. The non-profit status, if there's any surplus money, funneling that to global initiatives, should secure credibility from various countries. although another positive alternative could be that this puts political pressure on a country, whether it's China or Russia, that doesn't want an international nonprofit, or the United States that doesn't want an international nonprofit to help deal with the wreckage oil, and so outfits its own search and rescue of waste oil ventures to justify the choice not to seek or not to participate in a global initiative. And so either way, this spurs innovation. And I think it's worth a shot.